Okay, we are rolling. Please stand. And let us pray. In the name of the Father, of the Son, and of the Holy Spirit. Amen. Remember, O most gracious Virgin Mary, that never was it known that anyone who fled to thy protection, implored thy help, or sought thine intercession, was left unaided. Inspired by this confidence, I fly unto thee, O Virgin of Virgins, my Mother. To thee do I come, before thee I stand, sinful and sorry. O Mother of the Word incarnate, despise not my petitions, but in thy mercy hear and answer. In the name of the Father, and the Son, and the Holy Spirit. Thank you. Today was 1 through 8, is that right? So, yeah. Yeah, perfect. And have your worksheet out today. So we're looking at 1 through 8 out of 12.
That's what Hey, wait, Abby, no, it's like cultivating. Don't you know? You know what Mr. Do you know what like the Sacred Heart like? Oh, I just got it.
Oh, right. Yeah.
Do you know what like? So it's like cultivating culture.
Oh, the mission statement?
Yeah.
Oh, man.
Forming Catholics. It will. Isn't it like assisting families and forming Catholics?
The mission of Sacred Heart is to, Sacred Heart Academy is a parish apostolate designed to cultivate culture is one of them. Empower.
No, it's okay.
I'll look it up.
Were
Okay.
you supposed to memorize it?
No, it's just considered sort of a mark of calendar.
Wait, it's okay. We still honor you.
It's Sacred Heart Academy is a parish apostolate. The Sacred Heart of Jesus stood.
Okay, can I just see it? Like.
Oh, you can't write that down.
Thanks. Sorry, I didn't try to like interrupt you. She's like, yeah, I got it. Just this.
Okay. Those of you listening at home, hi, and you just watch me flub memorizing the mission statement of Sacred Heart. I'll work on it. Check out, please, your, I believe it was 6, let me look at that code number here. 6D-2, eccentricity. This problem is 1 through 8. And grab your favorite red writing utensil. Here we go. Number 1, the eccentricity is 0. Number 2, the eccentricity is radical 2. Number 3, eccentricity 0. Number 4, eccentricity radical 3 over 2. Number 5, eccentricity 1. Number 6, eccentricity radical 41 over 5. Number 7, eccentricity 0. And number 8, eccentricity radical 33 over 7. And it repeats. Going once, twice, right? Yeah, go. 4, yeah. Let me scroll up here. Number 4 is radical 3 over 2. We're cultivating conics right now. Just any of the repeats at all? Alright, questions? Any of you want to see dissected? Yeah. Number 2. Number 2 is not a circle. You will notice the subtraction. That's a hyperbola. X squared minus y squared minus 25 equals 0. Now getting the 25 on the other side is good. You get x squared minus y squared equals 25. Well, these markers will pop. Hang on a second. Here's how you can inflate this. This is really x minus 0 squared over 1 minus y minus 0 squared over 1 equals 25. It's still not in the right form. What's the one thing that needs to be fixed? Can't hit clue, by the way. What's the one thing that needs to be fixed? Go. Yeah, 25 has to go down to what? To 1. How? Divide everything by 25. So the horizontal radius, or A, well, actually, is equal to 5. Sorry. The vertical radius is equal to 5. Which one is A? Nick, which one of these is A? Horizontal or vertical? How do you know? It's the leader. They're both equal, so if it were an ellipse, it wouldn't be an ellipse, it'd be a circle. But yeah, this is the leader, because so it's got to be A. And the focal move is radical A squared plus B squared. So C equals radical 25 plus 25, which is radical 50, which is radical 25 times radical 2, better known as 5 radical 2. And then A is 5. So the eccentricity is C over A, which is 5 radical 2 over 5. These cancel. Radical 2. Does that make sense? Any other ones you want to see? Yeah. Number 4. Yeah, this was the one where it's a little on the annoying side of getting it in the right form. Let me get a fresh marker for this. Number 4 looks like this: 4x squared plus y squared plus 8x plus 2y minus 31 equals 0. First, priority. Josh, what shape is this thing? Ellipse. How do you know? Right. It's a plus sign. They're both positive, and the coefficients are different. Why isn't it a problem? Right. X and y are both squared. So in order to get this in proper form, break the x's and y's apart. 4x squared plus 8x plus blank plus, and then group the y's. Y squared plus 2y plus blank equals, and add the 31 to the other side. Does that make sense so far? Now, pull the 4 out here. X squared plus 2x plus blank. Plus, there's really nothing to pull out here. Y squared plus 2y plus blank equals 31. Now I'm going to compress. I'm kind of turbo speeding this because we got a lot of new notes to cover today. This is going to be x plus 1 parentheses squared. This was a double product, so you want to double it. The number that should have been here is 1, which means we're really... quick question. Does anybody need this? This first problem? I need a little more space. Yeah. There you go. Plus, and over here, there's an extra 1, but it's 4 times bigger than we thought. So really adding an extra 4. Look over here. This is going to be y plus 1 parentheses squared. The missing number is 1. So there's an extra 1 here. 31, 35, 36. You have to get the answer down to 1. Divide everything by 36. It's not just Jeff, please. 4 over 36. reduces to 9. I'm going to fix this to x minus negative 1 squared over 9 plus y minus negative 1 squared over 36 equals 1. So you tell me, Becca, take over. What is the horizontal radius in this problem? 3. What's the vertical radius? 6. Which one is A? Sorry? Why would you say that? It is bigger. Correct. That's exactly why. In a hyperbola, it wouldn't matter which one's biggest. This would be the leader, so it'd be A. But it is an ellipse, so it's whichever was the major, whichever's biggest. Focal move formula for an ellipse. Blaze. A squared minus B squared, which, go ahead and plug those in. What's A squared? 36 minus 9, which is 27. Good. Take over. Will. Reduce that. 5. Radical 27.
So.
Any perfect squares in there?
Yeah, 25.
As to divide it. 25 is going to 27.
Oh, sorry.
There is one, but it's not quite as big. 9 times what? 3. What does that boil down to?
So, 3 square root.
Right. So C is 3 radical 3. Katie, give me the eccentricity. How do you get eccentricity?
Isn't it B over A?
Correct. What's C?
C is radical 3, or 3 radical 3.
3 radical 3 over. Over what? 6.
Sorry, I was looking at the other.
Reduce it for me.
Radical 3 over 2.
Yeah. Radical 3 over 2. The 3 and the 6 go down to 1 and 2. There's your eccentricity. Does that make sense? Any others you want to see? Now is a good time to ask. Going on. Right. Okay. I'm going to give you a little bit of time to work on the last 4, but I want a batch of new notes. It's not going to be for the assignment you're doing now, because it's just the same stuff you're doing, but it'll be for the following one. Take out your notes, please.
Must be justice. Justice is
Find all intersections of y equals x squared and y equals 2x. Go ahead and write that down. First of all, can somebody tell me what shape this is? Mary, take over. What shape is this? Bravo, what's this? That's a plain old line. That's not a conic at all. It's just a line, it's slope-intercept line. 2x plus 0. How do you find out, see who remembers this from chapters back, I think it was back in chapter 2 and in previous years. How do you find, there are several methods to find out where two lines cross. Give me one. Go. Sam? Graphing. Give me another one. Elimination. Give me another one. Okay. Graphing, elimination, substitution. There's another obscure one. I was curious if anybody remembers it. Kramer's rule, which does determinants of matrices. You can use any method you like. It's nice to have multiple methods because some are easier than others. But When you have two lines intersecting, you could do substitution, elimination, graphing, Cramer's rule, etc., etc. This is not two lines. These are a line and a parabola, which means that elimination won't work in this case, in this example. If they're asking for two lines, it will work. Any ideas why elimination wouldn't work in this? Like elimination is when you're trying to get one of the variables to cancel. Yeah. Yeah, one of the x's is squared. There's no way you'll get these to cancel. They're not like terms. They won't add. So elimination is stuck. If they were both squared, I'd say maybe you have a chance for elimination to work. This one, not so much. Another one, Cramer's rule. Won't work. Cramer's rule is only for lines. Cramer's rule is when we used to take the two equations, just strip out the numbers, turn them into matrices, find a 2x2 matrix, which is like downhill minus uphill, and blah blah blah, and then you find the solutions. This will not work this time because this is not a line. So there are two options. You can graph it, and you can try substitution. Let's try graphing this thing. Again, graphing is not my favorite method, usually because it's tedious, and sometimes because it's not accurate. If the solutions are fractions or decimals, God help us as far as getting the solutions. If they cross at like 1/3, 2/7, there's no way in God's green earth that anybody's going to get that by graphing. Yeah, that looks like it's crossing at 3/17, -5/7. Nobody can do that that I know of. This might work though. Can somebody tell me how to graph this top one? Abby, how do you graph y equals x squared? Like, where's it start?
The center.
Yeah, right at 0. And what's the pattern?
Over 1, up 1.
Yep.
Over 2, up 4.
Over 2, up 4, and I think that should be enough, I hope. Yeah, it's a parabola with vertex at 0, 0. Height multiplier of 1, so it's normal. And it just goes upward. So it's not going sideways because y is the leader, it's a regular up-down parabola. It's all right. Somebody graph the other one. Ray Clark. Where do you start? Yeah, it's really 2x plus 0. So you start at 0, so you use that twice, and then what? Up 2? Over 1. Now that's in the middle of nowhere. Do you remember the trick by which you make an accurate line? What if you want to get like 4 or 5 points on the same line? Remember the trick for that? You got 2, how do you get the next one? It's not hard, but it's, what would you do again? How do you get that second one? What did you use? The slope. Do it again. So you rise 2, run 1, then do it again. Rise 2, run 1, and you get a surprise. Solve the problems for me. Megan, what are the two intersections? 0, 0, and 2, 4. Got it. That's a teaser into the next section. I'm going to give you one more method though. Partially because that was lucky. Graphs usually are not that nice. Either they're fractions or they're just hard to graph. Or you, like me, you just have a wobbly hand, or if a cat jumps up on your lap or something, it spoils your graph, which, ask me how I know that. Let me just rewrite this again. Y equals x squared and y equals 2x. There's one method we didn't try yet. I want to step you through this because almost everybody gets the first part of this wrong. I want to try substitution. Substitution means get a letter by itself and plug it in. And the reason I like that method here is because you have variables by itself. I'm just going to try this and plug it in place for y. They say y is 2x, so I'll plug 2x here. You could have done it the other way around too. You could have taken x squared and put it here. It doesn't really much matter. So it looks like 2x equals x squared. Go ahead and write that down. Here's where about 50% of the people get it wrong. What is the most tempting thing to do at this point to try and get x by itself? Yeah. Anybody see it? Guess what like half the people do when they first see a problem like this? At least. And I did when I was in I have not memorized every single mistake I've ever made, just the really, really annoying ones. And this was one of them. They divide by x. It says divide by x, x equals 2. Thank you, I'm done. There's a problem. You're dividing by what? X. There's only one time I would complain about that, is if x happens to be what? 0. If x is 0, you've just killed all your loved ones in a 75-mile radius and all a bunch of innocent wildlife and heaven knows what in a big nuclear cloud. That's bad. I've never done it, but don't. Dividing by 0 is unhealthy. Unless you can guarantee me that x is not 0, I won't let you do it. Why? Because I value human life. Thank you very much. And here's actually the real reason why. Can you solve that with algebra? Go. Why not? You have 2 species of x. You cannot solve with algebra. Doing stuff to both sides is solving with algebra. Can't do that. What can you do? You must immediately do what? Sorta, kinda, but you have to do something first. If you can't solve with algebra, you must do something right away. Get the answer to 0. Quadratic formula needs it, factoring needs it, yeah. Yeah, go for it. How do you get this equal to 0? Katie, take over.
Just subtract 2x.
Yeah, subtract 2x from both sides. What would you get?
0 equals
X squared minus 2x. Now what can you do? Austin, take over. You could. There's nothing stopping you. That does work, by the way. It takes like 5 times as long. But you could, if you like the exercise. Let's see what we can do. Somebody mentioned earlier. GCF of what? What's the GCF? X. What's left behind? X, what's that? Minus 2. What solves this? Well, people who remember your first year algebra. Go. 0 product property. If something times something is 0, then you set both these equal to 0. Either x equals 0 or x minus 2 equals 0. So basically you have x equals 0 and x equals 2. By the way, look at the first solution you got. You were just saved from a nasty nuclear death there. X was equal to 0 and it would have killed you. Always divide by x. Here lies so-and-so. He or she divided by 0. How sad. Now we're almost done. I want to find the intersections of these. I have x's. What do I still need? Please. The y's. How many y's? Maybe. How many x's do I have? 2. Let's suppose x equals 0. Find y for me. Yeah, it's 2 times 0, which is 0. If x is 0 and y is 0, that's the point 0 comes 0. Make sense? No, but what the heck am I doing? Wow, that was stupid. Now pretend x is 2. Yeah, everybody was wondering, what's he doing? I wasn't doing anything, I was just fast. X equals 2. Mary, take over. What's y? times 2, better known as 4. Give me the point you just found. Which is exactly what we predicted. Does that make sense? If you have 2 x's, expect 2 y's, 1 for each. You got the x. You remember way back when you were taking 2 lines that cross? If you find the x, don't pat yourself on the back and move on to the next problem yet. You got to find the y. Same thing here. If you have 2 separate x's, you're going to get 2 separate y's, usually. Any questions there? What would happen if I plugged it in here? Josh, take over. What if I plugged in a 0 here? What's y? 0. Still works. What if I had a 2 here? 4. Still works. It works for either one of them. Whenever you have 2 lines crossing, you could plug the answer into either one. Same thing here. You could plug it into either one. There is one catch though. Before I get to the catch, does this make sense so far? I graphed it, and if you graph it and they happen to be nice numbers, great. Otherwise, I would recommend substitution. Substitution is guaranteed to work all the time if you do it correctly. Caution. If the system of equations has equations of differing, kind of a fun word, differing degree. Let me stop there for a second. What is degree? What does that mean? Abby, help me out. What does degree mean?
Like the power it's raised to.
Yeah, which power? If you had like 7 powers, which one are you looking at? Like x to the 5th, x to the 4th, x to the 3rd, x to the 2nd. Which one would you care about?
Highest.
The highest power. The highest power is called the degree. If they have different degrees, like this thing has a degree of 2, this has a degree of 1. That's a case where they have different degrees. If a system of equations has differing degrees, then you must, I'll explain this word in a second, back substitute into the equation of least degree. Let me explain that for a second. Go ahead and write it down. If you have 2 different degrees in your equations, back substituting means you got x, find y. So you're going to substitute it back. Does that make sense? That's actually why they call it back substituting, because you're substituting it back in order to get the other variable. You notice we plugged it into this thing to back substitute. We tested this and it worked. That was called lucky. As a general rule, if you have equations of differing degree, you must back substitute into the lowest degree one. First of all, it's easier. And second of all, I'll tell you why not. Otherwise, you have a 50% chance of getting solutions that are wrong. If you try and back substitute into the equation with a higher degree, you could do absolutely everything correctly. And you might get 4 solutions, and 2 of them are garbage. 2 of them work and 2 of them don't. And you'd have to test every single one of those 4 to find out which are good and which are bad. If you plug it into the lower degree one, you'll never have to worry. You just plug it in, you're done. Does that make sense? That's actually all I'm gonna take you through for today. That's going to be the notes we're gonna continue tomorrow. Tomorrow's Thursday. Yeah. And for now, I'm gonna give you the rest of the hour to polish off the last 4 problems of, what was it called? Is it 6D-2? Let me put that up on the board. 6D-2. This is gonna be, so numbers 1 through 8 were for today. And then 9 through 12 for tomorrow. And it shouldn't take horrendously long. So 20 minutes should be easily enough to do that. Any questions? Again, just let this soak in. Eventually, we're going to start finding out where 2 parabolas cross, where 2 ellipses cross, where a hyperbola and an ellipse cross, et cetera, et cetera. There can be lots of intersections. There could be 0 intersections. We'll see. For now, go to it for 6D-2 and call me if you get stuck. And people watching at home, see you later. I hope you feel better soon. Bye-bye.